Okay, so this is a new video, and here in this video, let me make sure the voice is there. So in this video, we are going to look at a problem, and the problem is to measure the frequency, not very accurately, but measure the frequency at an incoming signal. And if you remember, the T1 timer 1 had an option to derive its clock from T1 CK. So basically what happens is that there is the signal coming in, and the signal could be like this, and then like this, and then have a low frequency. Of course, I mean, these are going to be square waves because this is digital, but I'm just drawing, scribbling here. And basically what we want to do is we want to take time slices and count the number of pulses that you have in each time slice and check to see if it is above a certain threshold. Let's say you want to know if the incoming signal gets any higher than 10 kilohertz at any period in time. And that period in time could be 1 second, could be 1 millisecond, could be 10 milliseconds, whatever you want. That's the resolution in time that you want to look at things. And if the signal within that time period, so let's say this is one of the time intervals, if your signal does like this and then goes nothing and then does what and then something like this, you would count the whole thing. So you would not, because your resolution in time is going to be this. Let's say this is 100 milliseconds or 1 second, right? Then you would count the total number of pulses that you have in this 1 second, and let's say you're looking for 10 kilohertz. So if this count is greater than 10,000, 10 kilo, then you would turn on an LED which says yes, the frequency is higher than that threshold. If it's lower, you would turn off the LED. So the LED, let's say port B bit 2 is, let's say, off here, off here, off here, off, and then on here. And let's say this is again off here, but let's say you have a lot of activity here, then it would be on here and off here, and so on and so forth, right? And a strategy that I want to use, well, actually, you know what? It's a really, really good idea for you to stop the video now, pause it, think about how you're going to implement this, and even start scribbling some of the code, and then continue watching the video. So pause the video now. All right, now that you're back, so this is my strategy, and this is not necessarily the only way that you can do it. I can imagine that there could be other methods of doing it, but the way that I thought I would be able to do it would be to make this interval marked by T2, right? So I would set up both T1 and T2 as interrupts, because I don't want to waste my main time. And later, if you want, we can play around with mixing these implementations. So we could use an interrupt for T2 and use polling for T1, or the other way around. So both ways would work. And if you want, I mean, either at the end of this video or later, I can play with that idea and change the code. But essentially, what you want to do, as far as T2 is concerned, oh, and of course, I mean, there is one counter variable that is common between T1 and T2. Let's call it pulse count, right? And I don't remember what I called it in the code that I've implemented, but for now, let's just call it pulse count. So what you want to do is, when T2 happens, you want to set pulse count equal to 0. And then at the end here, you would ask, what is the value of pulse count? And if it is beyond 10K or whatever value that you want to have, then basically RB2 turn on. Otherwise, else RB2 turn off, and that should give you an idea whether or not you pass beyond that frequency. Who does the counting? Well, the counting is done by T1. So T1, whenever it receives a pulse here on this TK, essentially what it does is it's going to do plus plus pulse count, right? And that would give you the solution, right? Now, so this is a rough sketch of what I want to do. There's just one problem here, and that is I have two markings here for T2, right? Right at the beginning of T2, I'm saying reset pulse count. So pulse count maybe have gotten up to, 9K, not 10K. And you reset it. You say, okay, that's fine. If I was at 9K here, then I don't care. I can reset it back to 0 and let's watch it from this point going forward, right? I mean, of course, one could I'm thinking if there is any method of sharing. So if you have a lot of activity here, would you share it with here? But I guess the quantization that we are doing within the 1 second or 1 millisecond or what have you, it would be lost. So you wouldn't look anywhere beyond, before this point. Whatever happened. You just reset the counter, right? So going back to the problem I was mentioning. So here for T2, you're saying right at the beginning, reset the pulse count. And the beginning, what is the beginning? The beginning is, when you enter T2 interrupt, right? That's when T2 has counted the counter of T2 PR2 and TMR2 have become equal, and you are in the ISR, you're in the interrupt service routine of T2, and the first statement of T2 interrupt could be pulse count equals 0. But what happens at the end of this pulse? You don't have anything. You don't have any marker that says, you know what, T2 just ended. The T2 event, the next event is just going to happen, right? So if you really think about it, you don't have to worry about the end of this cycle. The end of this cycle is the beginning of the next cycle, right? So before resetting pulse count to 0, you could do all of this stuff here in the code. So this would come here, and once you're done with that, this part could come down here, right? So when T2 interrupt comes, it means that you have reached the end of the cycle, right? And that means that you have to check to see if the value of pulse count is greater than 10K. If it is, then set RB2, otherwise reset RB2. And right before you exit pulse count, you reset pulse count to 0 to be ready for the next cycle. Okay, so sometimes we do these mental images just to be clear, how the interrupt service routine is going to work and so on. And if you really think about it, that's pretty much it. That's going to be the skeleton of the code. The code is going to, in T2 interrupt, the body of T2 is going to do this stuff, followed by resetting pulse count. This guy, the T1 interrupt, is going to just plus plus count and get out, right? So, and of course, you would like to put a low count on PR1 so that when you do plus plus count, T1IF does get set. Unfortunately, I couldn't make that in my code. So in the code, I tried setting PR1 equal to 0 so that with the first occurrence of T1CK, they match and I get an interrupt, but that didn't happen. I think when you set it to 0, it's equivalent to setting it to 65536. So I think the lowest value that you can set PR1 is equal to 1. And in my simulations, I needed to see 2 pulses here to be able to see T1IF. But that's not a problem. If you're looking for 10K, then just change it to 5K. Each count of pulse count plus plus corresponds to 2 of these pulses, and you just here, instead of 10K, you would say 5K, and that should potentially solve the problem. So let's move on to the code, and I can show you the code, but always the problem with the code, and of course before I show the code, I'll show you the timing, the block diagram. But the problem with showing the code is I might have spent maybe 15 minutes writing the code and debugging it a couple of times and fixing the problems. But once I'm finished, I'll show you the finished product and I'll just zoom through it and scroll down and say, here's the code, here's what different parts do. So what I'll try to do is to put the brakes and try to walk you over the code, go as slowly as possible as if I'm typing it, and also tell you what mistakes I made when writing the code and what was the synopsis, how did the code behave. So just a reminder, timer 1 has this T1CK that we want to access, and TCS is the bit that you would use to route that to the counter. I would set the prescaler to 1. I set PR1 to 1 so that TMR starts from 0 and goes up to 1 and gives me the T1IF. And how did I know that TCS is going to select this T1CK? Well, the next page has the bits and it says when TCS is 1, when TCS is 1, your external clock from TC1CK pin on the rising edge is going to cause TMR to go up. And if you read the manual carefully, it's going to tell you, and I think I did mention that in class too, that on the rising edge of the signal, TMR is going to count. On the falling edge, T1CF is going to act. So your compare is going to be activated, or I guess it would be activated when TMR1 matches PR1, but this is going to hold on to this signal until this signal goes low, and then you're going to have T1IF. So that's why I say it's counting pulses. And now T2 is pretty similar to T1 in terms of the prescaler stuff, except that T2 doesn't have this external pin coming in. So that's another reason I chose here. I chose T1 to get this T1CK here, but T2 to keep track of doing the 1 millisecond or 10 millisecond or what have you. So in the code, I have set up, in fact, I borrowed code from what we had. So this is stuff that I borrowed from lab number 1 to set your RB2 as an output pin. And of course, there's one thing that you have to be careful about. So we're talking about RB2, and I'm setting my TRIS-B to 0, which makes all the 16 bits of my port B as output, but that might have a conflict with the input pin. So if I go, and I don't remember where was the pin diagram, I can look for T1CK. So yeah, page 4. So on page 4, T1CK is multiplexed on RA4. So there is no problem with RB being all output, but although that's an overkill, right? I mean, it's probably better to just say TRIS-B bits dot TRIS-B3 equals 0 just to make RB3 or maybe TRIS-B 2 equal to 0 to make RB2 output only. But you also have to do RA4 as input, which I haven't. And of course, I mean, that's another thing to check with the manual. Sometimes when you program timer 1 to receive input from T1CK, the hardware automatically makes RA4 an input pin, so you don't have to make TRIS-A as an input. I think that is the case, but you can double check the manual. So my code doesn't touch TRIS-A. Maybe I should have. So that's something that I haven't checked. Now the rest I have borrowed from the code that we wrote in class, the T1 first, something like that. So I just borrowed the code from timer 1 to give a 1 millisecond delay and just changed all the 1s to 2. So T2 con equals 0, PR2 15999, TMR2 equals 0, T2 con bits dot T on equal 1. And note that we are lucky that timer 1 and timer 2, at least in the bit positions that the bit is defined for both of them. So for example, T2 doesn't have a TCS, the clock source. But if it has T on, it's the most significant bit both in T1 con and T2 con. So I can just copy paste the code and change the numbering there. And also in terms of enabling the timer, so this is again borrowed from int first int t1, something like that. So there was a code on Moodle that I used, and here I had to change everything. Now I just changed IFS 0 bits t1 IF to t2 IF, and it worked. This one didn't work because the T2 IP is in IPC1, not IPC2. So, but I didn't notice it until the compiler gave me an error, and I checked that. So just to make sure we do a recap, T2 IP, you want to know where it is. So you just look for T2 IP, and here you go. IPC1 is the register. IPC0 had T1 IP 012. And T2 is in a different register. So you just change that, and then you enable the interrupt. Okay, then down here I'm setting up T1. So T2 was set up to give me delays every 1 millisecond, but that could change. I mean, you could say I want a resolution of 500 microseconds, or you might say I want a resolution of 1 second. 1 second is enough. So that's how you would change things. If you want 1 second, then you would play with the prescalers of T2 and make 1 second interrupts happen. Now T1, I reset it, set the source to be the T1CK, PR1 set to 1, TMR1 reset to 0. Now, one mistake that I made in the first version of the code that I wrote, I could see that I never go to the interrupt routine of timer 1, no matter how many stimulus pulses I give to it. And then, after a while, I realized that I forgot to put this line, which turns on the timer. So timer 1 was off, and that means no matter how much I turn on the interrupt enable for that, it's not going to help. I'm not going to get an interrupt there. And then, so main is nothing but just set up and an empty while loop. Let me show you the bodies of these. Now, first off, I had to define a volatile pulses T1. Okay, so this is the one that is counting the number of pulses that you get. And I defined it volatile because both T1 and T2 interrupt are using it. Now, this is T1 interrupt, and essentially what I'm doing is I'm resetting the T1 flag increment pulses, nothing more. I'm just counting. I don't have anything else to do. And then in the T2 interrupt routine, I'm incrementing MSECs, but this is just for debugging purposes. You can just eliminate this line. We don't have to know what millisecond number we are in. But just in case later you want to, add a display that shows the millisecond as an integer, and turn on or turn off your port B to show that you're above the frequency. And here I'm basically saying if the pulses is greater than a constant pulse count threshold, which I defined up here, pound defined pulse count threshold, and I set it to 10 because I wanted to do debugging here, so I set it to a low number. If that is the case, then set RB2 equal to 1, otherwise set RB2 equal to 0, and regardless, go ahead and reset pulses T1, the counter, so that you start fresh with the new period and count from 0. And if you want to simulate this, essentially what I can do is I can set how do I simulate? Well, I guess what I can do is I can put a breakpoint here and execute it. So I'm going to stop here at the first 1 all right, and then I can just say go ahead and do this. So for the first one we didn't get anything, and now we're back to main, and this is going to go for a while, right? This is going to go for 16,000 instruction cycles. So maybe I can give a pulse now. So fire the pulse. Did it work? I can take a look at TMR1. It hasn't counted 1. So it did count 1. Let's give it another pulse. And what happened? Oh, as soon as it becomes 1, because I think I clicked twice. Then it goes back to timer 1 and it does increment this pulse T1. And what is pulse T1? Let me delete WREG1 and WREG2. So if I say pulses T1, the value is 1 right now, and I can go ahead and do a couple more. And the count is, sorry, not the count. Pulses T1 is 3. Now in the code I set it to 10. Maybe 10 is too high. Maybe I'll just change it to 3. Where is that defined thing? Oh, this is a different code. So maybe, yeah, here I don't have the defined. This is a different version of the code. So if I say pulses above 3, then let me recompile. And so let's get out of this 1 millisecond interrupt, and now let me give a pulse. And with the first pulse we did go to T1. Let me give another pulse and another pulse. So this is what I said, that I need 2 pulses to get to the interrupt, and number of pulses is now incremented to 2, and then give it another pulse and another pulse. So I go to T1 IF, I increment pulses to become 3, maybe give it one last pair of pulses. So I'm here, and now I can, so I'm done. I've added 4 pulses, and I can just hit play, and that's going to continue the rest of the 16,000 cycles. And after the 1 millisecond mark comes, my timer 2 gets activated, and then I'll just go ahead and check to see if pulses is greater than 3, which it is in this case, and I set RB2 to 1, and reset pulses T1 to begin a new 1 millisecond mark, and that's going to continue and do the job. Let me see how long it is. If it's not too long, it's too long. Maybe I'll do another video in which I'm going to play with changing any of these guys into any of these 2 interrupt implementations into polling. Okay, so that's it for now.